In our today's lesson, we'll be looking at pressure in liquids, and we are going to look at the formula on how to determine pressure in liquids. Now that we know that in solids we get pressure when we take the force and we divide by the area, that is the area at which the pressure is being applied. But in liquids, how would we get the pressure, since liquid might not have a definite area, isn't it? Yes. Therefore, it means that we must get a different way of getting the pressure applied by liquid, maybe at a certain point in a container or wherever the liquid is. So, when we are looking at the pressure in liquids, first we must understand the volume of the liquid. How do we get the volume of a liquid? For us to get the volume of a liquid in a container, then we must understand that volume is given by cross-sectional area times the height. Volume is given by cross-sectional area times height. So for any given liquid in a container, we get the volume when we get to multiply the cross-sectional area times the height. So this one, we can call it area times height, which will give us area times height, AH. So that one we can call it AH. But then, if the volume of the liquid is AH, how do we get the mass of a liquid? We know that the mass of a liquid, the mass of any liquid is given by density times volume. Mass of any liquid is given by density times volume. So this means that for us to get the mass, we multiply the density, which is denoted by a certain symbol known as rho. So we can say that the mass of a liquid is given by rho times its volume, isn't it? Yes. Yes. But from the previous section that we have here, we realize that the volume is given by area times height. So we can substitute this volume here to this point and say that the mass of any given liquid is given by rho times what? Area times height. So you realize that the mass of any given liquid now will be given by rho area times height. That is now the mass. But also we said that pressure is given by force over area, isn't it? Yes. And force is equal to mass times what? Gravity. Mass times gravity. That means that force is equal to mass, which is equal to density times area times height. So we are going to substitute the mass here at this point. The mass that we have here, we are going to substitute it at this point. Therefore, mass is given by density times area times h. Then we multiply by gravity. By gravity. So that now force is given by density times area times height times gravity. So the area here is a cross-sectional area. But remember, but pressure is equal to force over area, isn't it? Yes. Yes. So this means that pressure is given by force. What is force? Force is here. Force is density times area times height times gravity over area. Then at that point, we are going to realize that area and area at this point are going to cancel out, isn't it? Yes. Yes. So area and area are going to cancel out, and this one now takes us to the formula on how we are going to get the pressure of liquids. And this means that pressure in liquids is given by rho Hg. Pressure in liquids is given by rho Hg, which is equal to density times height times gravity. So this is the formula that we are going to dwell on when we'll be talking about pressure in liquids. When we'll be talking about pressure in liquids. So we can do an example and see how this formula works. We have a question. A container 16 centimeters high filled with the kerosene. Given that kerosene has a density of 800 kilograms per cubic meters, determine the pressure it exerts at the bottom of the container. So here we must look at the three aspects that we need to get our pressure. We need to look at the aspects, density. Then we also need to look at the height, and also look at the force of gravity. As we know, gravity is always 10 newtons per watt per kilogram. 10 newtons per kilogram. Height has been given in the question as 16 centimeters, which is simply equal to 0.16 meters. Then the density of kerosene has been given as 800 kilograms per cubic meter. Therefore, with these three aspects, we'll be able to get the pressure that is being applied by kerosene at the bottom of the container, having a column of kerosene up to 16 centimeters. Therefore, we just need to understand that pressure in liquids is given by density rho times height times gravity. And this means that we take the density 800 kilograms per cubic meter times height, which is 0.16 meters, times gravity, which is 10 newtons per kilogram. And this is going to give us 1,280 pascals. 1,280 pascals as the pressure that is being applied at the bottom of the container by kerosene. Remember, 1,280 pascals is also equal to 1,280 newtons per square meters. Remember that 1280 pascals is equal to 1280 newtons per square meter. Did you understand something?
Yes.
Yes. You can follow us for more lessons in physics. Thank you for your time.